Solve the quadratic equation over the complex numbers. In part A, this quadratic is set up in a way that enables us to use the square root method. Since our variable squared is by itself on one side, we can take the square root of both sides. When we take the square root, we have to consider the plus or minus, and that plus or minus is applied to the constant side. So what we end up with on the left is that the square root of the quantity squared cancels each other out, and the square root of x squared is just x. On the right-hand side, we have plus or minus the square root of negative 36. This can be written as plus or minus negative 1 times 36. And because we have multiply under the radical, we can split that radical. So let's wrap around and anchor the left-hand side again with our x. We have plus or minus. Splitting the radical, we now have the square root of negative 1 times the square root of 36. So this gives us plus or minus. The square root of negative 1 is I, and the square root of 36 is 6. So our x is equal to plus or minus 6i. And these are the solutions to the original quadratic equation. In part B, we're going to use the quadratic formula in order to solve for x. As a reminder, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. To use the quadratic formula, we must have 0 on one side first, and then we'll identify the a coefficient, the b coefficient, and the c coefficient. A is the coefficient on x squared, which in this case is 1. B is the coefficient on x, which in this case is minus 2. And c is the constant, and in this case that value is equal to 5. So now we take our a, b, and c and plug them into the quadratic formula. Let's start with the opposite of b. So we have negative b, and in for b we're going to plug in negative 2. So this is the opposite of our b coefficient, plus or minus the square root of b squared. So let's open up a hole for b and input negative 2. That quantity is to be squared, minus 4 times a times c, opening up variable holes for both the a and c coefficients. A is 1, c is 5, and then following the formula, we want to write all of this over 2 times the a coefficient, which in this case is again 1. Now we'll simplify this quantity and anchor that left-hand side with x is equal to. In the numerator we have positive 2 now, plus or minus the square root of. Negative 2 quantity squared is positive 4. And then we're subtracting the product of 4 times 5, so we'll be subtracting 20. And again, all of this is written over 2 times 1, which is 2. Continuing to simplify, we have 2 plus or minus the square root of 4 minus 20 under the radical is negative 16, all divided by 2. And the square root of negative 16 is going to be 4i. So this becomes 2 plus or minus 4i, all divided by 2. And we can simplify this. Let's split this numerator, giving each of those numerator quantities a denominator of 2. So we have 2 divided by 2 plus or minus 4i divided by 2. And from here we can simplify. 2 divided by 2 is positive 1. Plus or minus, 2 divides evenly into 4, leaving positive 2. So this gives us plus or minus 2i. Our complex solution is now in the standard form. This actually counts as 2 solutions, 1 plus 2i and 1 minus 2i. There are 2 complex solutions to the original quadratic equation.